What's up guys, it's Spaceman. What's up guys, it's Spaceman Dan, and I'm coming back at you with Keith's project. Dude, you're learning about some friggin' galaxies and quasars and stuff. So yeah, like, enjoy the video.
These may look like normal galaxies, but they are much more luminous compared to any normal galaxy. Such galaxies are called active galaxies. The core of these galaxies is typically very bright compared to the rest of the galaxies, especially at wavelengths other than visible. The reason for this is due to events occurring from the galactic center called the active galactic nuclei. They even show signs of activity such as star formation. Active galaxies are classified into three types: Seyfert galaxies, radio galaxies, and quasars. Seyfert galaxies resemble normal spiral galaxies, but their cores are 1,000 times more luminous. Seyferts were first classified as type 1 or 2, depending on their emission lines shown by their spectra. Most energy coming in the Seyfert comes from the compact regions in its nucleus. Seyfert galaxies are named after Carl Seyfert, who first described this class in 1943. Radio galaxies is a type of active galaxy that are very luminous at radio wavelengths, with luminosities up to 10 to the 39th. The radio energy released comes from two huge radio lobes that cover a large area, about 1 megaparsec. These radio sources are almost universally found hosted by elliptical galaxies, with a few exceptions. The minimum energy stored in the lobes of a powerful radio source might be 10 to the 53 joules. A quasar is a massive and extremely remote celestial object, emitting exceptionally large amounts of energy and typically having a star-like image in a telescope. The first quasar that was discovered was in 1950 and was named as 3C273. As of date, nearly 200,000 quasars have been discovered. It has been suggested that quasars contain massive black holes and may represent a stage in the evolution of some galaxies. Quasars eventually die. This happens when a supermassive black hole consumes all of the matter in the accretion disk and there's nothing left for it to feed on. In an active galaxy, the central black hole may be millions to billions of solar masses. The accretion disk is whole clouds of interstellar gas and dust that come too close to the black hole and are torn apart. Calculations show that about 10 to 20% of the mass of the accretion disk is converted to energy and radiated away before the rest of the matter disappears into the black hole.
Hey guys, what's up? It's Spaceman. Oh, what's up? Hey, sorry guys, it's Spaceman Dan, and I'm here with Keith's video. So the Greeks looked up in the sky and they're like, whoa, that's way milky. Nah, I'm just messing with you. They didn't say that at all. They looked up in the sky and they're like, dudes, what does that look like? What does that look like? That looks like milk. So we have a word called milk. It's Galaxies, so that's what they named it. So we derived it into the Milky Way off of what the Greeks thought looked like milk. Isn't that so cool? Dudes, so like the Milky Way is a galaxy, but there's another galaxy, and it's called Andromeda. And like Andromeda and the Milky Way, they're gonna collide within the next 4 billion years. So like, in a little bit, not that close, but in a little bit. And like, they're gonna collide, and when they collide, they're gonna form an elliptical galaxy. It's like these two spiral galaxies making an elliptical, which is like mind-boggling. But like, you can't make this stuff up. When they collide, the scientists, dudes, they're gonna call it Milkdromeda. I mean, I couldn't even make that stuff up. So like, the Milky Way is big, but there's something bigger. It's called the local group, and it's where all the galaxies hang. So in our local group, there's Andromeda, which is the biggest galaxy. Then there's the Milky Way, which is like a little smaller, but like pretty much the same size. And then there's another galaxy called the Triangulum Galaxy. That's like smaller than us, but like still pretty up there. And there's supposed to be 30 other galaxies in this local group. So I mean, that's so cool. It's like 30 buds you get to hang out with, man.
This video is brought to you in part by green olives. This has nothing to do with the project, I just enjoy green olives.